Here's the installation manual, owner's manual, and quick start guide. Next is the NMEA 2000 cable. This cable provides power and NMEA 0183 data. This is the quick release mounting bracket, and that's the base for the mounting bracket. This package contains the transducer, mounting brackets, and transducer instructions. There's some mounting screws and a flush mount kit. This is the transducer and cable. Intended to be mounted on the transom, it comes with several brackets. First job is to remove some of these old instruments. This is the depth instrument that is no longer working. And just getting them out of the dash will give me a little better access to the wiring. When I installed the autopilot, I added a cable to power my Garmin GPS 72, and it drew power from the CHIRP network and supplied NMEA 0183 data at these ports. I'm going to put the new transducer inside the hull, just forward of the old transducer. To run the transducer wire from the port hull, I had to go into the aft cabin. The wire comes up through here from the bilge. And goes all the way under the boat. It's the curly wire, the one that's not lying flat. Pulling the drawer out of the starboard aft cabin, exposed the other end where that wire comes, and it goes through a hole up there, and then up through this cavity where the steering box and everything is, and way back there you can see the hole where the transducer cable goes through to the dash. Well, the dash is sort of put back together. That's the transducer cable, and I'm going to have to make some connections here for the power cable. I'm going to draw power from the cable that plugs in here. The installation is complete, pretty much. Everything is working except the depth sounder. Basically that means the chart plotter is working. The NMEA 0183 connection is feeding speed to the speed instrument. I wouldn't expect the depth sounder to work just yet because it's just lying inside the hull. I haven't stuck it down with silicone. I'll get to that later. The quick release bracket allows the unit to be stored down below, out of the weather. This is the first step in constructing the box for the transducer. I have these Venetian blind slats that are plastic. So we're going to cut 2.5 inches. Make several cuts with the razor knife. Don't have to cut it all the way through because it will fold and snap. The next length will be 10.5. We need two 10.5 lengths and two 2.5 lengths. Now we join the corners. I heat the hook knife by holding it in front of this torch flame. The hot knife melts the plastic and welds the corners together. I'd like to get a watertight seal, but I'm going to use silicone sealant inside the corners anyway, so this is not a critical operation. It would probably have been better to join the corners with epoxy, but I didn't want to wait while the epoxy cured. And there we have the joint. Not real strong, but strong enough to hold it together. The silicone sealant will go in here later. Now, unfortunately, it won't fit in the corner clamp to do the next one, so that has to be freehanded. Put it on a flat surface so the bottom will be square. And simply line up the edges. And there's the box. Run a bead of silicone inside each corner.
Now we're ready to try to install the box. Both sides seem to fit fairly flat, so it doesn't matter which one we apply the sealant to. Remember that the sealant goes on the bottom edge. The idea is to have enough sealant to fill any gaps. And we just slip it back in. I put some weight on top of it, hoping that that will press the edges down into the silicone bead while the silicone sets up.
With the aid of a small endoscopic camera attached to my computer, I was able to inspect the silicone bead and make repairs where needed. It looks like there was some water in the bilge that prevented the bead under the forward port corner from bonding to the hull. It probably would have saved me quite a bit of work if I had realized that water was there and dried it out before I tried to install the box. I tried bedding the transducer in silicone sealant, but I couldn't get any depth readings. A test with an inch of water in the bilge was successful. The box limits the transducer's movement and allows it to be submerged with much less water, keeping the rest of the bilge dry. I trimmed away a lot of excess sealant so I could run a new bead. Guiding the knife by the view on the computer screen while holding the camera with the other hand was really challenging.
After considerable effort, the box for the transducer is installed and ready for testing. It's pretty dark down here, so it's difficult to see it, but I need to get some water in that. And I think I'll be able to pour it in from a glass. And now the question is, will that hold water? And I can see water is just pouring out the other end into the bilge. So there's more work that needs to be done.
After I ran a fresh bead of silicone sealant and pushed it into the gap with a tool, it seems to be holding water.
After I applied some more silicone sealant, it seems to be holding. The transducer is in place. I may have to remove it and dry it out to let the sealant finish curing, but I think we're good here. Although I can see at the forward port corner, we're going to have a little spillage if I don't withdraw some of the water. Now we're picking up depth readings. I don't know why they're intermittent, but they seem to be accurate. So I think maybe we're done.
A test run through deeper water gets solid depth readings.